So the arithmetic sequence, the next value is always what? Either plus or minus a number from the previous one. Plus or minus. This is not going to be plus or minus. It's going to be either what? Multiply or divide. Because when you're dividing, you're multiplying really by the 1 over that number. Reciprocal there. So the next value here will be r times the previous one. And what's r? Let's take an example and see what that is. I might have something like this. 3, 6, 12, 24. What do you notice that each number, the next number is what? It's 2 times the one before it. 3 times 6, 3 times 2, 6. 6 times 2, 12. 12 times 2, 24. So r here is actually 2 for that example. Or you might see a problem like this. 8, 4, 2, 1, 1 half, and so forth.
Now you're dividing by 2.
So the next number we can say is the previous one divided by 2. If you don't like dividing by 2, you're multiplying by what? A half. So r here is really 1 half. If you want to use that equation, that it's a multiplication. So r for that example is 1 half. R for this example is 2. And just like the other one, if I want to find the 20th number, the 30th number, I don't want to list them all. Is there a way to get us there? So we'll take the first one, 3, 6, 12, 24, and so forth. And I want to find the 50th number. What is that? I don't want to have to list them all. I don't have time for that. So to jump to that answer, we have an equation that will take us there, and it says, bless you, if you want to find the nth number, you take the first number, multiply it by r to the power of n minus 1. What was r for this example? R equals 2, right? So let's see. I want to find the 50th number. It's going to be the first number, which is 3, times r, which is 2 to the power of what? 50 minus 1. That number is going to be big. 2 to the power of what? 49. Good luck on that number. 2 to the power of 49. Times the 3. Go ahead. 1.6888496 times 10 to the power of 15. Huge number. Massive number. Yep. I always tell people, just go out and be kind to 2 people. Open the door for them. Just 2 people. Be nice to them. Say good morning. Open the door. And hopefully each one of these will be just kind to 2 people. Each one just to 2. You don't have to go crazy with it. By the time we go through 10 sets of them, guess how many people are being kind outside? 10 sets. So, here we go. You're kind to how many people? 2. Each one of these is going to be kind to 2 more. So that would be what? 2 times 2? 4. Each one of these is going to be kind to 2. 2 times 2 is what? 8 now. Then 16. So let's do it 10 times. Let's go through that sequence 10 times. If we do it 10 times, what do we have? How many? It's A1 times R to the power of n minus 1. The first number is 2. R is what here? 2 to the power of 10 minus 1. So you end up with 1,024. Guess who used that logic there? What is that, Mary Kay who does the makeup? The Tupperware people? Let's just bring 2 for your friends. You can have a party there. We'll give you sell them, you make money. Because you bring in 2, this one bring in 2. By the time you go through 10 sets of them, they have 1,000 people working for them. Doesn't take much actually to build that. The other thing, if you have some disease, you infected 2 people and they keep infecting 2 more, and that's what happens in the HIV, especially in Africa. Because we don't have the treatment for them. You infect 2 people, 2 people infect 2 more, each one 2 more, 2 more, 2 more, 2 more. By the time you go through the sequence, you have millions of people infected. If you want to add the first, let's say 1, 2, 3, 4 numbers, I know I can add them, I can see them here. But is there a way to get to the sum? What's the sum of the first 4 numbers of that one? Let's look at it. 2 plus 4 plus 8 plus 16. What's the sum? 30. Do we have an equation that will get us there? It says if you want to find the sum of the numbers, it's going to be equal to A1 times 1 minus R to the power of n divided by 1 minus R. Obviously, R can't be 1. Because if R is 1, all the numbers are the same. You don't have an arithmetic sequence. If R is 1, what happens to that fraction? What are you dividing by? 0. That's why I say R cannot be 1. Because you'll be dividing by 0. Can't divide by 0. Let's take this example. So if you want to add the first 4 numbers, we know the sum is 30. Let's see if this one agrees with us. What's the sum of the first 4 numbers? It says take the first number, which is 2, multiply it by what? Multiply it by 1 minus, what's R here for this one? 2 to the power of 4 over 1 minus R, which is 2. What's 2 to the 4? Is it 16? 1 minus 2, which is negative 1. 2 times what? Negative 15. Do we have negative 30 over negative 1, which is what? Is it the same answer? Yep. So it does work. It looks like a lot of work here just to add the number. Just go ahead and add them. Well, it's true. But what about if I want to add the first 30 numbers? 40 numbers. I don't want to calculate them all. Now, where do we use arithmetic geometric sequence? Well, we'll put your money in the bank, because the bank is not supposed to lose money. Let's say you have your money invested in, I don't know, bonds. and somehow whoever invested your money did a good job with it. You gave them $2,000 to invest. And at the end of 1 year, they managed to give you 5% every single year. 5%. So 2,000 times 1.05, you got a 5%. So after 1 year, you have 2,100 because you get 5% interest. The year after that, you get 5% interest on this. 2,205. Then next year, you get 5% on that. Is 2315.25. Notice if you watch the problem, the first year, how much interest you got? $100. The second year, you get what? $100,005. Why? Because you get interest on the $100. The next year, you got what? $115,025. You get interest on that $205 of interest you collected. So you get an interest on the interest on the interest every year. If you're not sure what R is, you take two consecutive numbers and divide them. And you end up with what? 1.05. Because you're making 5% interest. So whatever your money plus the 5%, that's why it's a 105. If you divide this by this, that's 105. If you divide this by this, that's 105. So this is now you deposit this, year 1. This is year 2, year 3, year 4. You are 28 years old, and you want to take the money at 62. How many years? 62 minus 28. So how much money are you going to have after 34 years if you leave that money sitting there? It's a one-time deposit of $2,000. You're not putting that every month. It's a one-time deal. And it's just the money collecting interest. What is that $2,000 will be worth? Well, let's look at it. It's A1 times R to the power of n minus 1. A1 is the initial deposit, the 2,000. And what is R here? 1.05 to what power? 34 minus 1, which is 33. Take your calculator and do that 105 to the power of 33. It's 5.003188542. You multiply that by the 2,000 that you put in, and you will have $10,006 and what? 38 cents if you round it to near cent. A one-time deal.
Plus 34 years.
Huh?
Plus 34 years.
34 years. Long time. Inflation probably worth less than 2,000 by that time, but that's okay. Because you're only getting 5%. Imagine if you put them in the bank at a 1% or 2% today. That 2,000 will be $2,010. Not enough for a pizza. Now, if you go to add all these numbers, in this example, it doesn't make any sense to add these numbers. So what if you add how much money you had every year? It means nothing to you, right? That number does not mean anything in this example if you were to add them. So the sum would be silly, but if you do want to add all these numbers for the first 34 years, you can. But does that tell me anything? No. Now, on the other hand, if you decide, you know what, it's not a one-time deposit. I'm going to deposit $2,000 the first year, and after that, every year I'm going to increase my deposit by 5%. So the second year you deposited that number. The third year you deposited that number. The fourth year you deposited, and you went through it for 34 years now. But look at this. Year 34, how much you have to deposit? $10,000. Because every year you're depositing what? 5% more than the year before that. So if you did that now, how much money would you have? 34 years. Oh, a lot more than that.
Yeah, I was gonna say.
Look at the last year, you put in 10,000. The year before that, probably 9,000 some change.
I was just thinking of double or something. Like something's wrong. I only get 10,000.
So let's see, it's going to be what? What's the equation for that? First year times 1 minus r to the n over 1 minus r. A1 is the first year, which is what? You deposit 2,000, not 200,000. 1 minus r is 1.05 to the power of 34, that's inside that, over 1 minus 1.05. Let's do 1.05 to the power of 34. Five point 253347969 divided by 0.05 with the negative sign. $2,000 times, if you subtract 1 minus that number, that's negative 4.253347969, and you divide that by negative 0.05. Oh yeah. You will have $170,133.92. That's just your deposit, right? Whatever interest in addition to that. That's how much money you put in. Because we increase it every year by 5%. Some companies will say, yeah, you can, like, any of you can open a retirement account and put money in it. And you can use that logic. The question is, can you afford it? If you can, that's a different story. But like in my work here, we have what we call tax shelter. I can open an IRA, a Roth IRA, or can I call it like retirement money. I can put in, because of my age, up to I think $24,000 a year. Yeah, good luck. Can't afford to put $24,000, but if you're fortunate enough to can put 24, I might start with. I think I started when I was young here. I think I started by putting $100 a month or $50 a month, and you add to that. You know what? After 1 year, that wasn't really that bad. Let's add $10 more, like 10% or 15%. And that's what I started doing. Well, let's add 10% more. The following year I went back to them, that wasn't bad. I managed it. Let's add 10% more, because you get raises every year. Let's add 10% more. So you do that, that's just your money. In addition to that, whatever interest you collect, I guarantee you there's $500,000 or more sitting there, interest alone. You hear me talking about retirement because I go and talk to senior citizen, and I see where they're in. I'm like, oh my goodness, I don't know how you guys gonna live on it. Really. I see with my mother-in-law. She's on Social Security. That's it. Good luck living on that. They never plan. At that time, years ago, nobody planned. Gotta go to nursing home. They charge you what, 4 or 5,000 a month? Yeah, okay, Social Security is going to pay 4 or 5,000 a month? You're getting like 10,000, 12,000 from Social Security. A year, not a month. And live on that. So that's my advice to all the young people. Stop putting money aside. Social Security is not going to carry you. If you have a retirement plan through work, it's great. If not, start your own. Never mind buying all these nice cars. Don't worry about the cars. So that's what actually geometric sequence is. The next one is always the previous one times r. R could be more than 1, could be less than 1. If it's something like this, 8, 4, 2, 1, you notice r is what here? 1/2. That's my fourth number. 1, 2, 3, 4. If I want to find my 10th number, I got it. Which is what? A1 times r to the power of n minus 1. Eight times, what's r? 1/2 to the power of 9. I'll be like the book, doesn't like decimals. What is 1 to the 9th? 1. What's 2 to the 9th? 512. So your answer is what? 8 over 512. Can you simplify that? Yes, I can divide by 8. What's 512 divided by 8? 64. So that number will be 1 over 64 if you go through it. Notice as the numbers start to shrink, can you add them all the way to infinity? Because after a while, this number gets what? What's the next number? What's after 164? 128. What's at 1 after 128? 1 over 256 becomes small number. It's not worth adding. So at the end, you'll see your sum will stop to add because what are you adding is not worth adding. But if the number is getting bigger, you'll never be able to add it all the way to infinity. Because if you keep going this to infinity, you can't. Because the number gets bigger, then it becomes infinite. And you can't add it. But when r is less than 1, that number starts to shrink as you go farther and farther into it, and it's not worth adding. You'll have a real sum to that one. But I can add here the first which one is this? That's A10. Now I can add the first 10 numbers, or the first 50 numbers. What's the sum of the first 50? N times what? 1 minus r to the power of, we said, what was it? 50 over 1 minus r. N is what? 50? I deserve this. I'm using like massive numbers. 1/2 to the power of 50 over 1 minus r is what? 1/2. You'll see that number is almost a 0. Try that. Here we go. 1/2, that's 0.5 to the power of 50. Ready for that number? What do you notice about that number? Can you see the exponent? I don't know if it shows on the screen. 10 to what power? Negative 16. That means move it how many places to the left? Put 15 zeros before that. Isn't that a 0? So this becomes almost a 0 here, divided by 1/2. So guess what that sum? It's 100. Because after a while, you're adding a smaller and smaller number. It's not worth adding. We'll get to that in the last section, or in the next section. Can you add all the way to infinity? Because what will happen when that number is actually less than 1, as you raise it to a high power, it goes to a 0. If this number is more than 1, you can't add them. This becomes infinite summation. Go all the way to infinity. You'll see that number goes to 100 if you add them. And I will stop here.